But one thing I was wondering is if maybe you could show me how to solve a problem. Like, I saw you use this try APL. Oh my god. Why is that so big? Like, maybe you could walk me through solving something.
Sure, yeah. Let's, we can actually use the, I'm not sure if you want to use an Euler problem, but we can also do the LeetCode problem that I mentioned earlier, like the max ice cream, which I think is it's a good example because it's a different solution. So the APL way of solving this is not like, so to recap, the problem was max ice cream. You're given a certain amount of money, $6, and then some ice cream cone prices, so 1, 2, 3, and 4. And the question is how many ice creams, what's the maximum number of ice creams that I can buy? So the first thing, so if you go, I guess you actually won't know these symbols, so we can just click on them in the top, actually let's try and do this. So if you go X and then backtick and then left bracket. Can you zoom in? Is that a left arrow or a right arrow?
You see that?
Yeah. Okay, so go backspace. I guess I should do this alongside to make sure that I'm telling you the right keys to click. So left bracket instead of right. So X and then backtick left bracket.
X, backtick, and then left.
We got
X, backtick.
Yep, and then just type in 2, 1, 3, 4.
2, like all.
Yeah, with just space delimited. Yep, and then hit enter.
Okay.
And now if you type X and hit enter, you're going to see that is those values stored in a list.
Okay, so I stored my values of ice cream.
And so now the first thing we want to do is we want to sort these. So the most idiomatic way to do this is to type X left bracket. And then backtick, and then shift 3.
What is that? Is that right? No.
Or actually, that was right, but I should have said shift 4.
Backtick, shift 4.
And then type.
So I'm looking at a weird arrow that points. What is it?
This is a triangle with a line through it. Yeah. And then type X again and right bracket, and then hit enter. So what this is doing is that symbol is called grade up, and if we actually show what the result of grade up is, it's the resulting indices if they were sorted. And so when you pass a list of indices to the bracket operator, it basically is going to do a reordering. So it's first going to get you the first index, then the second one. So if you actually, if you go, I believe Control Shift Backspace will get you the previous line. And then, yeah, if you just delete the brackets and the first X, it might be easier to visually see this. So this is the indices. It's actually, it's a bad example because the indices of the sorted values actually map exactly to what our original list is. So here, just swapping the 1 and the value at the beginning with the second value gives you your ordered list. So it's very coincidental that I just happened to give you.
Oh, that's interesting.
And so, yeah, if you go Control Shift Backspace twice now, it'll get us back to our sorted list expression. And so now you build up these expressions right to left. So the next thing that we want to do is a plus scan on our sorted numbers, which is going to give us the total prices if we were to buy the first element and the total price if we were to buy the first 2 elements, aka the ice creams. And the way we do that is if you hit home or go to the beginning of this expression, and then you just...
Is this like a scan?
Yeah, so it's a plus and then scan, which is like the left slash.
Plus.
Yeah. And so if you hit enter now, this is going to give us the incremental sums of the numbers 1, 2, 3, 4. And in our example where we had the amount of money that we started with is 6, basically what we want to do is we want to figure out how many of the resulting prices in this plus scanned array are less than or equal to 6. So we want to turn this into a Boolean array where a 1 represents a number that's less than or equal to 6, and a 0 represents a number that's greater than or equal to 6. And the way that we do this is if you go Control-Shift backspace.
I think I just do up arrow.
Or yeah, up arrow might work as well. And then if you put 6 at the beginning of the expression, and then backtick Shift 6. That's the transpose. So yeah, backtick Shift 6.
Shift.
Or maybe I've got this wrong. Oh no, sorry, without the shift. Backtick 6.
Oops, backtick 6. There we go.
And so if you hit enter on this now, we're going to get our Boolean array.
Oh,
and what
okay.
this...
So it's applying this greater than or equal to 6 on
Correct,
each element.
yeah. And what this now represents is basically all of the ice cream cones that we can buy. Because a property of a plus scanned array is that it's the incremental sums, and if you're doing that on a sorted array of sort of ice cream prices, where the point at which the incremental result is greater than our money that we have, we can no longer buy anything. So at this point, all we have to do is do a plus reduction on this expression, and then we're good to go. So you do plus, and then the slash, that's the opposite of the scan. Except you do it at the beginning of the expression, but that was exactly correct, yeah. And then
nice.
that's the result. And I think like these examples are really cool because when you compare them to the sort of C++ approach, you're using a for loop with a bunch of state, and it's short circuiting. So as soon as you find a value that you can no longer purchase ice cream, you're just going to return the number of ice creams that you've got. But here, unless if the interpreter behind the scenes is doing that optimization, you're iterating over the whole array a couple different times. But it shows you sort of, this includes both a scan, a reduction, a unary transformation where you're checking at whether each element is less than 6. And if you want, we could turn this into an actual function.
With that same, whatever this was, right?
Well, so yeah, if you just take the last expression, yeah, and so call the function f, so you can just go f, and then hit, I believe it's backtick, and then shift bracket, which is going to give you the left bracket, will give you the arrow again.
Backtick, shift bracket, what am I, backtick, shift,
Yep.
left bracket? Backtick, shift, left bracket? No, I can get it from this list.
Oh, sorry, it's backtick left bracket without the shift.
Backtick left bracket. There we go.
And then put braces around. Well, so this will just assign 3 to f, which now.
Okay. Now I need a new name.
Yeah, you might need a new name now, so call it G or something. And then yeah, put a curly brace. Left curly brace beside that, yeah, and then a right curly brace at the end. And then we have to replace the x and the 6 because those are arguments. So we need to replace the 6 with alpha, which you just do by deleting the 6 and going backtick A. And then replacing the x with omega, which is backtick W. And this is and there's also a second x in there.
So same.
Yep. And then if you hit enter, now we've got a function g. And the way we call this with our variables is you go 6gx.
6gx. The ordering of calling this is not what I would have expected.
Yeah, it's somewhat stack based in that when you have a single argument, the argument's always on the right, and when you have 2 arguments, the arguments are on the left and right, and so you have like an infix function, which is a bit surprising to a lot of folks. But if you're familiar with like stack-based languages, it's somewhat similar in that typically the way that you evaluate something is you start on the right. In UCO, we're doing omega, grade up, omega, that's a sort. Then you do a plus scan. Then you do an alpha less than or equal to. Then you do a plus reduce. And so...
Is it? Yeah. It makes sense when I consider that everything... Like, it makes sense as an infix because everything is infix, right? Like, all these guys are infix?
In the case where they take two arguments, yes.
And then can I define my own, can I give some random Unicode to something
That
like
is one of the things that APL cannot do. Although there is a array language called Julia, which you can. Julia actually supports Unicode symbols as well, and you can end up with some very APL looking like code in Julia because of that.
Nice.
And
so I can totally see. Okay, so this made sense. Each step along the way, it's got a very nice REPL
REPL.
feel.
Yeah.
But I can see why this might be hard for me to understand later.
Yeah, it's one. I get this
I'm pretty new to this, so
I get this question a lot, which is, do people that know APL, are they actually able to like read it fluently and not have to stop at a line for 10 minutes and like slowly squint at it and be like, okay, what's happening here? I know what this is doing. I know what this is doing. So overall, this must be doing X. And the truth is, like, think about when we read English. When we read, like, it says off to the left, got a minute? Try APL. I didn't stare at the M, the I, the N, the U, the T, and the E in minute. My brain knows the word minute. It sees it, it reads it, and knows what it means. And the same thing happens after a certain number of hours with APL. Like, I'm a quote-unquote APL baby. I've only been learning this language for just over a year. But when I see omega bracket grade up omega n bracket, like, I know that that's the sort idiom. I know we're sorting. Like, I don't have to look at the individual, characters one by one. I see that as like a 4-character expression, and I know that that's sort. The same with plus scan and plus reduce. I know that those map to like partial sum and accumulate in C++. And so then all you're left with is the alpha greater than or equal to. And so very quickly, I might have to take a few seconds. Okay, so what is this abstract function doing? It might not make complete sense, but being able to read it, I very quickly could read out, well, we're just doing a plus scan of all of the elements that are less than or equal to alpha after having sorted them. And yeah, that might sound like gibberish to a non-array oriented thinking individual, but you'd be surprised how quickly like these kinds of idioms and patterns start to sink in. And especially when you're not naming your function G and you're naming it actually a meaningful name, you can get it.
Arthur Whitney would not approve of anything.
Yes, I mean, yeah, everything that Arthur does, and a lot of array folks do, they name their files one character. They name a lot of things one character. But you can write it's the same thing. You can write unreadable C++ and unreadable Haskell, and you can also write readable versions of all of these languages.
I can see, like, I mean, I do get the sense of like the point free flow that you might expect from like Haskell, where you have like whatever, like this is like G to H to X or something. Yep. Like I get the feel of my inputs traveling this way through my function, I guess, right?
Yeah, someone pointed that out to me, that my two favorite languages have support for tacit or point-free programming, and they both read linearly from right to left, which was a interesting observation. I don't think I love the languages because they read right to left. I think naturally we're used to reading things left to right, but it is an interesting observation that both Haskell and APL have that property.
Yeah, I really like one thing I love about Scala is it has a lot of the niceties of Haskell, but like it tends to do things like the correct order. F# also,
yeah.
Right? They use like, I forget what their operator is called, but it's like pipe,
yep.
Something like that. Like they do the point free, but in the opposite order, so that it reads
more like English text.
So that it reads left to right. Yeah. But the Haskell version is fine, where we do like X is F dot G dot, not X, I guess, whatever, T, my input. But like the place where this breaks down, I remember seeing it in one of your videos. Maybe you didn't find it either. But when this starts spreading over multiple lines, you're actually like reading backwards from the top of your function up. I always find that a little bit hard to follow.
the same person that pointed out the right to left also observed that it's probably not the order of left to right or right to left. It's the fact that it's linear is what I love so much about it. Whereas like in a Lisp without the threading macros to make things nice, you basically are evaluating something inside out. You go to the most deep call, you have to evaluate that argument, and then that gets passed to the function outside. Reading code like that is extremely confusing for me. Whereas if I can just read one operation, then the output of that operation, it's like bash in Linux or Unix, where you pipe the result of one operation to the next thing. Like, I think that's a very natural way to read and understand code. It's just one thing, another thing, and you just chain the output to each operation along the way. And Haskell and APL, you very frequently can get code that reads linearly like that. Sure, it might be making use of some combinator tricks and some point-free machinery, but I would rather learn that and have that knowledge in the back of my brain than having to like decipher this 6-line inside out with a bunch of parentheses everywhere. But yeah, that's just preference, right?
Yeah, and somebody said to me before that like the Unix like pipe is like the original functional programming. Like all you can really do in Haskell is like compose two functions together. A pipe is just a way to do that, right? It's like taking the input of one thing and passing to another.
Yep, absolutely.
And I guess because it handles more than one thing, maybe it's an array. I don't know. Is it?
Interesting. That's that's an interesting thought.
So I think that's all my questions. But like, what are you doing with your knowledge of array programming languages? Like, what?
At the current moment in time, I'm just a super curious, excited person that feels like he's stumbled on this island of treasure that people on boats that pass it sort of see it. And even though there's like gold lying on the beaches, there's some, I don't know, scarecrow that they're, look, it looks scary. And so they just keep sailing by. And I stumbled on this island immediately and saw like a treasure chest of gold and was just looking around being like, why is everybody like, sure, okay, there's the Unicode symbols. I guess that looks a bit odd, but like, this is unbelievable. Like the paradigm is just, it's mind blowing. And, so I'm walking around this island by myself, bumping into a ton of folks in the, J community and the APL community, that are super happy to have, curious people show up at their doorstep. And there's so much gold. Everyone's, not monetary gold, but like, intellectual gold of finding out ways to think about problems. They're happy. They're like, everyone that uses the language loves the language. And, so I think I've heard on the podcast that like anything that, elicits such extreme reactions, either on the side of like, I absolutely love this versus I absolutely hate this, it's always worth like exploring. Like, why do people have such extreme reactions to it? It's either like, oh, it's a write-only language. It's the most unreadable, horrific language. And, there was a blog a couple years ago that said, top 10 dead languages. And of course, APL was on the list. So I just, I'm curious and I'm walking around this island. I've gotten a chance to talk to so many folks in the community, and they're super excited. And I don't think there's going to be a ton, there's going to be 2 orders of magnitude more APL code or J code getting written, 5 years from now. But I'm excited to share my passion, whether or not the comments on the YouTube videos are going to be like, there's a reason APL died, 2 decades ago. I don't get many of those, but every once in a while I get someone who just says it's faster in C. Well, that's the same comment that they post on every video though. But there's a ton of people that have, reached out, whether it's from the podcast that I'm doing or from the YouTube video, because whenever someone asks me about APL, I can't stop talking about it, as I'm sure you've observed. And a handful of folks have said, I've really started looking into the language and it seems super cool. And even if no one ends up writing production code, I think knowing about the history, whether if it's APL or if it's Lisp or if it's Prolog or functional languages like ML and Haskell, I think it's a benefit to our community at large, for just people to have more knowledge about different programming paradigms. And hopefully it will lead to, in the future, it being less like us versus them, like Java programmers versus C++ programmers. Like it's one of my big things is just like, we should just be friendly to every single community. Like, just because a language has garbage collection doesn't mean I can't be a friend with a developer that like codes in that language. Like, you know, some people say, I've heard people say that like any language that doesn't have a GC, a garbage collector, it's like not worth using. And yet I've seen talks by people that implement languages that have VMs behind them, like Java, and Dart is a more modern one from Google. And every single one of those VMs is implemented in C++. Like Lars Bach is one of the creator of Dart, and he has this talk where he talks about working on Smalltalk and Java and now Dart and a bunch of other languages, and he shows a comparison, a bunch of things. The one thing that was consistent across all the languages was that the VMs were implemented in C++. So like, even if you think languages that have GCs are like, you know, the bee's knees, there needs to be a language that can implement the VM in that language. So anyways, I wish everyone would be more friendly, and hopefully that'll start to be the case if there's more people out there talking about how every language is awesome and we can all learn something from each other.